Start recording. Okay, I think that's all set. All right, let me pull up the one-stop shop. I will share my screen to bring you guys along. Cool. All right, so we got the one-stop shop. Let's see what the sign-ups look like this week. Okay, so we got a few of us. Furkan was first, actually.
Yeah.
And Furkan, so you're I think maybe new to the study group. Like I said, I recognize your picture, but maybe you haven't. Maybe it's from elsewhere in Discord.
Actually, I'm not new, but I wasn't able to contribute to the group, so
okay.
It will be my first step. Yeah.
Okay. Cool. Awesome. So, do you feel like do you understand what the study group is? Do you want any like context or intro, or have you been around for the past sessions?
No, not really. Actually, I've been around.
Okay.
I was just listening.
Awesome. Cool. Well, yeah, great to have you picking up a topic. That's awesome.
Thank you. Thank you.
And so yeah, we can
enjoy.
Yeah, we can start off with your topic, and then it looks like Zane can give another update on PicoDAO, making crazy progress over there every week. And then yeah, I actually had some work that I did for the predator-prey model that I can show off. So looks like we have 3 topics today, and then we can kind of yeah, just go from there, see if there's any other interesting things that come up. Otherwise, we might end early, I guess. But cool. Does that sound good? Did anybody want to like throw in another agenda item or have a question before we get started? No.
Hello. I have a friend that is interested in this working group, but when I send the link, it says this is private somehow. I'm not sure if he could get in or I don't know.
Was it a link to the Discord voice channel?
Yeah, exactly.
Yeah, I'm not sure. It should be public here. Let me post it again.
I think you might have to do some verification to join the server, the token engineering server.
Oh yeah, if they're not in the Discord server yet, they might need to join that.
Yeah, maybe
that might be where the issue is.
Not in didn't do the verification. Okay, I will try to make it.
Cool. Yeah, and if they're having issues with it, I think I can actually verify them manually if you give me their Discord handle. But yeah, if they click the link, I think it should automatically bring them through the verification process.
Yeah. Okay.
Cool.
Thank you.
Awesome. Anything else before we jump into it? All right. Cool. So Furkan, you want to get us started?
Yeah, sure.
Awesome.
I'm sharing my screen. Can you see it?
Awesome. Yeah, just loaded for me.
Okay then. So my name is Furkan, and today I'm going to present you a project. But first of all, I need to say that this is not a generic project of mine. So this is the paper. I put the references. So this is the paper I'm going to present today, and my motivation is to apply this project, this paper, to cadCAD, to learn, to have experience on cadCAD. So let's start. So motivation of the paper, it's a project about multi-agent reinforcement learning framework, assumes of a group of autonomous agents that choose actions independently and interact with each other to reach a Nash equilibrium. So the assumption of the paper is that when all agents are rational, the most natural solution concept is one of the Nash equilibrium. And the motivation of the paper is to provide a generic fast algorithm that converges to Nash equilibrium. So it's basically two agents. Why is that? By the way, I put it as a Bayesian games. It's a Bayesian Nash equilibrium because there are two agents in the game and they have limited information regarding to the payoff of each player. So basically, the two agents compute closed-form soft optimal policies under an entropy regularization. So this is the generic algorithm that the paper provides, the entropy regularization algorithm that explores the policy space close to the given priors. So before the game theoretic part, so basically this is the game. Actually, in the paper there are three different games, but for the sake of simplicity, I just only picked one game. This is the pursuit evasion game. So there are two players. The pursuit evasion game plays 4x4, 6x6, and 8x8 grids. Both agents seek to avoid the collision with the obstacles. The black cells are the obstacles here, and the pursuer tries to capture the evader by being in the same cell as the evader. So as I told you, this is a Bayesian game. This is the reason that it's a Bayesian Nash equilibrium, because there are two different types of players, the pursuer and the evader. The goal of the evader is to reach one of the evasion cells, as marked in red in those cells, without being captured by the pursuer. So two agents simultaneously choose one of the four actions, so north, south, east, or west. So each execute action results in a stochastic transition of the agent's position. So it's a zero-sum game. One pursuer and the one evader. So the game G is equals to the tuple. The S is the finite state space, and the action of the player and the action of the opponent. And the T is the transition function, and to choose the actions, the player uses a Markovian policy. So as it's a reinforcement learning, it's a Markovian process, and the agents receive rewards R, and the gamma is the discount factor. So actually, this is the backbone of the paper. I mean, there are many algorithms in reinforcement learning, and for example, the Minimax algorithm that already solves this problem and that already played this game. But the backbone of the paper, they try to provide a faster algorithm, the entropy regularization algorithm. So basically, it's the SNQ2L is the name of the algorithm. So basically, this is the environment that for one player. So in the past, so I mean the fast algorithm. Imagine that there is no fast algorithm, and it's already been, I told you, tested that there is a slow algorithm like Minimax algorithm operator. So basically, in each time step, the agent calculates all the queues, and it's a reinforcement learning, and in each time step there is a queue update, and the agent will take an action according to this learning process, according to this queue update. So, but what they are doing is they put another fast algorithm, and this is actually the step that I am right now doing, trying to understand the algorithm. What it does is actually there is a feedback mechanism between these two algorithms. So the two values are used asynchronously. It's a Kullback-Liebeck. Sorry for my pronunciation. It's a QKL stands for Kullback and Liebeck regularization process. This is the entropy algorithm. So in each time step, an agent, the fast algorithm updates, the pi stands for the policy, so it updates the Q value, the action the value action function, but also it updates the Q update of the standard Q, the standard algorithm, and then it will update the policy, and this policy will update the Q value of the fast algorithm. So, but how is it faster? So this is the question. This is I am trying to understand the algorithm. The algorithm works in this way, not in each time step. The standard, the slow algorithm works. So the frequency of the standard slow algorithm works for not each time step. So it works for a particular frequency. So that's why it is faster than the standard minimax operator. And does it work? Basically, it works. So the paper says that, okay, we generated this faster algorithm, and the both players reach to a Nash equilibrium at the end of the game. So this is the motivation of the paper. This is what the paper is about. But what I'm going to do is basically my motivation is to apply this algorithm, this model to cadCAD, to run a Monte Carlo simulation, and I will say that, okay, the both players, the both agents reach to a Nash equilibrium for a particular time period, after a particular time period. So this is my motivation to apply this algorithm in cadCAD. So this is a small presentation. I hope you enjoy it. So basically, this is what I'm going to do. Are there any questions?
Awesome. I was curious, like, is there like sort of a reference point for like how much faster, I guess, using both algorithms is compared to doing the traditional min-max algorithm?
Well, yeah, I mean, I don't remember. I put the paper there. So, but basically, this is also what I'm going to test via cadCAD. So, I mean, how many time steps it will take in Monte Carlo simulation for both agents to reach to a Nash equilibrium. This is what I'm going to test. But I don't remember the finding of the paper. But I put the paper on the one-stop shop.
Cool.
Are you planning to test with the same initial conditions each time, or are you going to randomize those?
So this is also another, actually, this is the handicap of the paper. They say that there needs to be a good start, or like the start of the game is actually the question. I mean, they didn't randomly choose the cells that the pursuer and the evader will start the game for the sake of the efficiency of the algorithm. But what I'm going, I mean, this is the good question actually. So I can, when I code this, I can randomly start the game. I mean, randomly put the evader and the pursuer in the game, different cells. Or I can exactly duplicate what they did, how they started in the game. So this is what I haven't decided yet.
Makes sense.
Yeah, really cool. Awesome. Do you have an idea for your first step for trying to replicate this in cadCAD?
Actually, my next step to understand the algorithm, how it works, basically, and how can I apply this to cadCAD. Probably it will take 1 or 2 weeks. Most probably 2 weeks. After 2 weeks, I will be able to present the cadCAD version of the project.
Awesome. Cool. And so, when you're comparing the algorithms, is the main metric that you measuring just time? I mean, or speed, I guess.
Yeah,
would be time.
I mean, how many time steps it will take
Yeah.
for both players to reach the Nash equilibrium is
Yeah.
the question.
Okay. Cool. Awesome. Are there any just curious, are there like variations of this game with like more agents, or does it get more complicated? Not that this isn't complicated, but
There are different games, but with two agents again.
Yeah.
And actually, one of the games is the rock paper scissors game. But I don't know. Maybe the next project might be apply this algorithm to different games. Like, if I'm not wrong, one person is already working on the rock paper scissors
Yeah.
project. So that's why I actually, and for the sake of simplicity, I only picked this Percy Vader game. But maybe for the next project, we can apply this after testing with this game. Maybe we can test with different sort of games. But again, like with multiple agents, like more than two, I don't know. I'm not sure.
Mm-hmm.
Yeah.
Cool.
Thank you.
Yeah, really interesting. I'm excited to see you try and break these formulas down, or the algorithms down into cadCAD.
Yeah, I don't think it will be a difficult part, but like the most difficult part, for example, I don't know, the quiet person asked me like, so what will be the starting point for the agents? I mean, this is a good question. Like such things are more difficult than like deciding such questions. I don't know. Such things will be most difficult.
Yeah, definitely. Awesome. Any final questions for Furkan? Comments? Has anyone tried to simulate games like this, like rock, paper, scissors? Like, I know Tyler was looking into that one, but has anyone used these game simulations with either cadCAD or other simulation tools before?
There's a game of life simulation in the cadCAD repository.
Ah, like the board game of life.
No, the little cells that grow and what's it called? That should be something.
The finite automata.
Ah, okay.
Right.
not the board game. I was like, that's interesting.
I've seen it used in poker.
In poker, yeah.
So advanced, so I don't even try to simulate it myself.
Yeah. So is modeling stuff like this have any like fundamental differences to I guess I'm thinking like token systems, like token economic systems? I mean, this is agent-based, but
I'm not an expert on token-based systems, so I'm not the person to answer this question.
Well, I think if you start with the similarities, they both have policies and actions. In the case of a simulation like this, there's an optimization taking place. So there's a search for best answer, which in the case of simulating in token engineering, I think has merit for exploring what can happen. But in the real world, you wouldn't be able to guarantee that people are necessarily pursuing optimal actions.
You could measure how far off the optimal actions they are, though, right?
Yeah, if you can get an accurate picture of the space.
But that's also only if you are agent-based in token systems.
I think an agent-based exploration provides one way of exploring the space in a token economic system.
Yeah. All right, cool.
One of the reasons that I choose the Bayesian Nash equilibrium is that there is a limited information. So I mean, not each player doesn't know exactly what are the payoff of of the other agent. So they have a common prior belief about what might be the payoff of the other agents. So, for example, in this game, so they don't know exactly what are the payoff of each other, basically. So maybe, I mean, I'm not an expert on token economics, but so maybe this limited information might be related with the games or with the simulations in the token economics. I don't know.
Mm-hmm. All right, awesome. Well, thanks for the pitch. Excited to see some progress in the next couple weeks.
Thank you. Hopefully.
Yeah, I'm sure you'll get there. Cool. So I think, let me double check. I think next on the list was Zane.
Cool.
Back with the PicoDAO.
Yeah. With this time with maybe more like sort of economics at a higher level. So yeah, a much more intense looking diagram. Okay, just to recap, because I'll keep it really brief because I think most people have already heard this. So I've been working on this thing called PicoDAO, and so the basic premise is like, how do you sort of think about open source, like sort of funding, or like sort of development and things like that, and how do you have like sort of an open economy for open source? So instead of just like sort of core contributors getting rewarded, how do you say like anyone that's participating in the ecosystem can then like sort of capture some of the value that's available for development? And so where we left off last week, before I do this, was that I kind of distilled things down into the smaller sort of document that kind of just talks about the development cycle, how like demand kind of flows in the product needs, how there's like pending goals, and like development incentives, and like what that kind of feedback looks like for like active participants and things like that. And how that kind of leads to achieve goals and a better product and utility evaluation. So the feedback from last week was basically saying like, well, like what does things look like when you have like sort of a monetary policy and like where can that go? So the approach I took to sort of modeling the system was to sort of think about like the way that like you have funders, and then if I could abstract away the things around it, around like sort of this economic black box model. And so I think that this kind of applies to sort of most projects within the space that have like some sort of pool of money that can then be distributed towards like sort of contributors. And it seemed kind of like this economic black box model is really the thing that drives whether or not you get these things over here, which are like sort of active participants in like sort of your ecosystem, which is a big problem for open source. So projects like Babel.JS are like woefully sort of underfunded, but not only that, they can't get enough sort of active participants really to like do all the stuff in the ecosystem. All right, so that's a recap, and here's like sort of where I ended up. So if we start in the upper right corner, we have these new sort of addition, which I'm calling funders. So you can imagine funders are kind of the people that are like maybe buying your NFT, PFP. Are there anybody that wants to contribute towards the initial funding of the project? And so this could be either the founders themselves, this could be VCs, etc. And so basically funding flows into this thing, which is like the total available funding pool. And then from that, this total available funding kind of increases the willingness to make a product bet, where a product bet could be like a feature or something for development. And then product needs feed into the willingness for a product bet, because a product need is just like, well, maybe the product in the beginning needs to like function. It needs to actually work. It may need a website. It may need any of that sort of thing to get going. So all of these kind of feed into the willingness to make a product bet. And then that all feeds into increase for sort of available product funding. So like that is correlated to how much you're going to be willing to pour into the product. And available product funding, of course, removes from the pool of available funds. And that may be something like, oh, maybe we have servers to pay for. Maybe there's some sort of fear of running out of money. I don't know. It just sort of reduces that. And so as like sort of available product funding increases, or it has like you have some of that available, then that funding can go into ongoing concerns for development. And like sort of sprint funding represents the amount of value that you have within sort of the sprint. And then all of that then sort of drives towards the individual monetary development incentives. So the more sprint funding that you have, the more that the individual can get rewarded for doing development. And so there are actually a couple different development incentives for active participants. So there's this non-monetary development, which we'll touch upon, and then there's the monetary development incentives. And so this kind of both feed in the same direction as development incentives, of course. And then this kind of leads towards the more development incentives. So if you can make $5,000 for 2 weeks working on a sprint, then there's going to be more people that are willing to sort of take on this kind of responsibility. And so the pool of sort of active participants will grow in the same direction that your development incentives grow. And so as the pool of active participants grow, you could say that the expected amount of individual monetary development incentive goes down proportionally towards that, depending on, of course, the total development incentive, which could be non-monetary things. So if a project is hot or people see a lot of value in learning a skill set, that's a non-monetary development incentive. That like this monetary development incentive going down doesn't necessarily affect the total pool of like sort of active participants. It's not like sort of constraining it. Okay, so we have these active participants here. And the more active participants you have, the more like sort of knowledge of the system, the ecosystem, and the network grows. And the more likely you are to increase the number of achieved sprint goals. So these are things that people put on the docket to sort of handle some of the ongoing concerns that like drive the whole economic engine. So as we like sort of trace along this route, we'll see that active participants lead to knowledge and network, which lead to sort of more utility, and utility can of course increase in the individual like sort of monetary development incentives. So there's this kind of reinforcement loop here, where sort of everything goes in this like little circle. And then if you look here at the number of achieved sprint goals, you'll see that that kind of like leads potentially to a better product, which of course leads to increased utility. And so like if we kind of step back and take a look at like the constraints, we see this thing called product needs. And product needs generally originate from, let's say, the users, or it could be the founding team, it could be funders, just more broadly, this group of people. And so they have a set of demands which drives the product needs. But when you have a need that's unfulfilled, it becomes an unmet need. And unmet needs reduce utility. As utility goes down, then the individual non-monetary development incentives trickle down, and that kind of gets reinforced. So the fewer development incentives, there'll be fewer participants, and there'll be fewer achieved like sprint goals, etc. So the other sort of thing here that's been kind of dancing around is this economic black box. So ideally, users create sort of demand for whatever it is that you're doing, and that demand feeds into whatever your economic model is. So in a 10K NFT PFP, that economic model could be social clout, it could be any of those types of things where there is some small economy or some larger economy on like resale value or like sort of royalties. Um, and so the demand for the product like really feeds into this economic black box model and can correlate to an increase in total available funding. So a functioning economic model probably has the same sort of correlation where demand cycles into this model and then funding sort of cycles out. And sort of the other thing to kind of look at is that it takes a while to get these economic black box models going. And so what actually ends up mattering as an input a lot is met funder expectation. So basically these funders, they're funding this for some sort of reason, and these are called the sort of funder expectations. And with some delay, this ends up creating unmet funder expectations. And these unmet funding expectations change their willingness to fund, which then affects future funding, which would then apply into total available funding. So for projects without economic models or without senses of like sort of revenue or any sort of incoming funding, it's all sort of drained from the initial funding. And most of the project hinges on your ability to meet funder expectations. So unmet funder expectations are highly bad. So, and I think this is like the traditional sort of VC funding model where the funders or the VC people have certain expectations for what the product will do and like what like sort of growth looks like and what a sort of roadmap looks like. And the individual startup person's ability to like sort of meet these funder expectations either through the economic black box model, which you'll see the slide here, or through whatever sort of product expectations that they have. And that affects available funding, which affects the amount of participants that are going to be within the ecosystem. And so, okay, that was like my attempt to sort of expand the CLD to capture like what goes on with sort of the economics. And I left this as a black box because really you have a lot of flexibility to try and nudge these development incentives or nudge the available product funding or nudge these funders' expectations in many different ways. But I thought that this would be a nice way to like sort of frame things for like getting into what this black box could be. Okay, so that's pretty much all I have.
Well done.
Thanks.
I think as I'm listening to it, it touches on a lot of challenges in software development, whether open source or otherwise, related to how do we decide what to build? How do we decide what goes into a sprint? How do we correlate what we're building with delivering value to the customer? So very interesting from that standpoint, which it made me wonder, how would you look at it in the context of something like a bug bounty?
So like a bug bounty is kind of interesting because it's very similar. I wouldn't say I had like really thought about it too deeply, but I would say that maybe the bug bounty is kind of like a one-off. It's like a one-time funding event, and like if you have the money, so I guess like the way sort of Gitcoin worked in the beginning itself was as a platform for other people to pay them to organize like bug bounties and sort of hackathons for these other organizations that couldn't actually capture the active participant problem. So I think a bug bounty just reduces the total available funding, but it doesn't actually, I think, build too much on this knowledge network. Because I think there's something to be said for being able to re-engage the same participants versus turning over your participants all the time.
A bug bounty would be sort of a short-term solution, whereas with a more sustained funding model, you're building a more core team and sustainable group. Is that correct?
Yeah, that's what I think. Because I think the importance of this knowledge network is actually a lot more like valuable than you realize, because not all like sprint goals are equal. So like, for instance, if you wanted to rewrite Geth without Peter, who like manages like he's like the lead dev on like the Geth team, you would probably have a really hard time. But Peter, of course, didn't start out with such a high like knowledge base of the network. And sort of the other issue there with like even say like Geth is that like Peter is maybe like one of the only people with this knowledge network or this particular level. So by doing the bug bounties, you don't necessarily build the right incentives to get people to keep participating, the same people to keep participating in the system. So you want to reward sort of experience points.
Yeah, that's interesting. A lot of important things in there.
Mm-hmm. Yeah, this is really cool. I like that. I mean, it's obviously zoomed out a lot more than the loop you were showing last week. So it's cool to see from more of a macro view. The two positives coming out of the economic black box, is that basically like profits from like, I don't know, the external economy, like people paying to use the product, or people paying for, yeah.
Yeah,
and then those
so
profits go into the funding, or they go back to the funders.
Yeah, exactly.
Okay.
So like that's kind of like the interesting thing. So I think this is the thing that is like sort of missing from, I think, a lot of sort of open source projects, etc. They're too reliant on this initial funding or one-off sort of grant events. And so that makes it really hard to get these people ever engaged over and over and over again to build this. And so like this economic black box could do anything really. So that's why I wrote it as a black box.
Yeah, no, it's cool to think of this generally. Sorry, I didn't mean to cut you off. Yeah.
Oh, no. I was just going to say that like, because the cool thing is that this could be like a bonding curve where users are buying into it, and then like maybe they're locked in, or there's some sort of like wedge or delay that allows you to capture some total funding. This could be like the regenerative like economics stuff that Giveth is doing. So like short-term credit swaps, more or less, where the users are putting the money into the economic black box. This economic black box is investing it somewhere with low yield, low risk funds, and then they're giving it to wherever it needs to go. And then this goes back into the total funding, which backs a liquidity pool, which then sort of like causes the token to appreciate. Like there's lots of things here, and I don't think that like there's any one particular model, but I do think that demand is probably going to be positively correlated to what goes on here. And like what goes on here in this black box could also be like the cost of operations. So that's probably going to be positively correlated to the total available amount of funding. Yeah.
Wouldn't you say cost of operations? Isn't that part of like the development incentives flowing to active participants? Is that like the operations you mean? Like paying the participants to develop?
Well, that's
Or
definitely
rewarding?
one portion. That's a good question. Because like that's one part of like sort of the cost of operations and in terms of available product funding. But the other things are like more like fixed costs or variably fixed costs. So it could be the cost of running a server on,
Mm-hmm.
say, AWS. It could be the cost of paying transaction fees
Yeah.
on an L2. And so like those are actual like fixed costs that like you can't avoid like running.
Mm-hmm.
Like for instance, I have a project that I'm doing, which is like, well, not a project, I guess a startup that I'm doing called Swapland, and it's an NFT for NFT trading marketplace where I'm going to try and apply these models to get sort of active participants as like developers. And so like the issue there is that in order to have like a marketplace that works well, I need to have sort of indexers. So I either have to use the graph or I have to run my own indexer, which I'm doing right now, or I might need to pay for IPFS rehosting storage on a gateway. So all of that ends up being like a cost that's kind of a fixed cost of running whatever the thing is. So is that kind of confusing, or do you think it would be better if I like broke that out into something away from this black box model?
No, I think it makes sense because it's not necessarily, as you said, related to the active participants developing the products. It's more about like the remaining part of the business model, sort of. Like if this whole system is like represents the business model, then you have the flywheels on the left half are kind of more focused on the development incentives and the participants contributing to the products. But then there's, as you said, a lot of other costs and business logic that's not, it's necessary, but it's not directly related to those loops. So I think the economic black box makes sense. Yeah.
There's probably an implicit cost around trust operations as well. And I'm thinking of, developers that know the system and that you know well are probably implicitly more trusted than new developers. And so maybe that results in a cost efficiency in terms of the amount of code review and process that you have to go through for code updates.
Yeah, that's kind of one of those interesting things. So, like the way I've been seeing that is that really, like the idea is to decentralize the notion of a core team. And so, in order to be a core team member, you earn sort of experience points for like every like code commit that you make or every sort of contribution. And those experience points could then be exchanged for some sort of like funding, or you can hold on to those. And then that gets you sort of higher up the sort of chain. And so you could get like a larger stake of the development incentives or funding rounds and things like that. And by being a part of the core team, then you get paid like a salary or something like that. And so like at any point in time, anyone could buy you out, more or less. They could earn more experience points than you. And let's say the core team is only of a size of 10 people or 100 people. Then like if you're number 100 on the experience points list, someone could earn more experience and essentially buy you out of your like position by like sort of staking those experience points. They would be like sort of soul bound, and so that allows people to just like build more trust in the system and like to like become a core team member without having to be like necessarily hired, which is kind of an interesting thing. And so as you go up the sort of top 10 people, maybe you get access to keys. I don't know. There's a real trust issue there, like you said, because it's like, oh, who do you trust with the multi-sig? I don't know.
Yeah, right. Yeah, that's a really interesting thread to pull on. Well, I think these things exist implicitly the way software is developed today. And so something like this can make it more explicit. For example, a new developer coming into the system, I think the way things operate today may not have a good sense for what is required to build trust. And I think having a system like this could make it more explicit.
Yeah, I think so. Because it's like, I guess when I started software development many, many years ago, like 20 years or so, they were like, oh, yes, this is software level 1, and people would have these long lists of what it takes to make level 2, to make level 3. But I would say, like, yeah.
Go ahead.
I was going to say, I would say that, like, over recent years, within, like, with the mobility and motility of, like, the recent years, no one's ever in a job for more than 1 or 2 years. So, like, building trust or career plans have just kind of been chucked out the window unless you're at like FANG. So it's been like, and even FANG, like career progression is very unclear.
Yeah. Well, and they tend to run on annual cycles, right? So you get an annual review, you may get an annual bonus or salary increase, and the software development cycles are getting shorter than that.
Yeah. Yeah, it's definitely an interesting thread to pull on and to consider.
Yeah.
Cool. Yeah, I'm also kind of relating this to the token engineering ecosystem too. Like I'm thinking of like the TEC obviously has some initial funding, and then there's not exactly like sprints from an open source or from a transparent like token engineering team like being completed all the time, but like there's grants that are being there's money that's being granted to projects who are hopefully creating value for the token engineering community. And like also I think the knowledge or what do you call it? It's kind of small. The knowledge network I think is also really relevant for token engineering just because such a new field, and so anyone that has some experience with the tools or best practices is actually really valuable to have on a token engineering project. But then it's interesting because there aren't exactly these links total fund, like there's not really a business model yet behind commons. Like there's no economic there's no like value capture that contributes back into the total available funding. There is, I suppose, just additional or like new people in the community could or mint more TEC, which is kind of like funding going back to profits going back to the original funders. But it's so it's like a very similar model, but there's some of the important links like around the economic black box that are sort of missing right now.
Yeah, it's kind of interesting to think about that. Actually, I put a note of this here. TC grants process. How does that look?
Yeah.
In this like model, Because yeah, I think like the thing about the TEC is really the fact that the TEC is like meeting funder expectations.
Mhm.
And so like that causes a willingness to fund, which leads to future funding.
Mhm.
And future funding with some delay happens, and then that increases this pool, which
Yeah.
then allows you to then drop the grant, and that is like the sprint funding. And then this gives people some individual monetary incentives. But the thing that's really bigger right now, probably than this, is the non-monetary development incentives, which is the knowledge slash network that the TEC
Mhm.
builds. And so that probably drives a lot of development and gets you more active participants and things like that
Yeah.
over this like thing right here.
Mhm.
So it's interesting. I'd be curious as to like, yeah, how does the TEC eventually get to like some form of revenue?
Yeah. Yeah, I think that's actually a topic that is up for discussion these days. I've heard just I haven't actually been part of any of the discussions, but I've heard and read a bit on the Discord. Um, but yeah, I mean, if that could happen, if there could be some sort of like revenue model for the TEC, then that would be, I think, huge for kicking off a flywheel. I mean, obviously, like you can see it here for kicking off a flywheel of development incentives and then more active participants and developing the knowledge network. And yeah, yeah, I actually have
Yeah.
somewhere like a year ago, I forget who I was working with, but I went through the ecosystem value flows course at the TE Academy, and the ecosystem we were focused on was the token engineering ecosystem, and we had a lot of these same concepts of like the knowledge network and yeah, incentives for new projects and the amount of projects being completed leading to better products kind of thing. So I'll try and find that and see if there's like a position or something and see if that has any parallels. Could be interesting.
Yeah, yeah,
Cool.
for sure. Thanks. Well, I don't want to take up all the time.
Yeah, no
I
worries.
think next steps for me is probably um, to drill down into a little bit of the trust and career like progression thing, because I actually have a couple ideas about the contributor like this active participants, because like I'm not sure how to actually stratify it, because like when your CLD runs in like multiple iterations, so like there's like short term, there's longer term, etc. And like it's like I need to talk about active participant retention. So I probably need to break out active participants a little bit more. Yeah.
Mhm.
Yep.
And there are some examples of system diagrams that illustrate what you're describing, basically, that things are operating on different time scales. I think you'd have to go beyond causal loop, but I think there's a way to structure that.
Okay. Yeah, I'll have a look.
See if I can find something and post it in the chat.
Awesome. Thanks. Okay.
Sweet.
On to
Yeah.
here.
Cool. Yeah, that was a great presentation though.
Oh, thanks.
All right. So I finally got to, well, where'd it go? Lost my Notion page. There it is. Okay. So I finally got back to the predator-prey model a little bit last week.
I'm sorry, guys. I'm gonna have to bounce. See you next week.
No worries. So, yep. Thanks for joining.
Thanks.
And actually, all the work is in Lucidchart, so screen. Okay, so I think I last presented like 2 weeks ago, and basically realized that I had not set up the proper assumptions or initial conditions to make this model work. So it was kind of interesting to see how immediately it broke down. But yeah, so I've been working on the predator prey model and just keeping it really as simple as I can to just get an understanding of how these different pieces work together. So I'm really coming at it from like this like structuring almost a template for like which questions do we have about the model, which assumptions do we have, initial conditions. I'm taking some notes on like how we could add complexity eventually, which I do plan on doing, and then really just like using these assumptions to also build the formulas that represent the relationships between all of the variables in the system. And let's see. So I actually didn't really update any of the diagrams, but I did get to some simulations. So I think I'm definitely at an advantage relative compared to like cadCAD example, in that this system has been thought of and the math formulas actually exist and they're quite intuitive. If the assumptions are simple enough, at least. And so I could actually pretty quickly get to some simulations, and I just used Excel. So basically skipped all of the learning cadCAD parts that I was planning to do, and just wanted to like, and yeah, it was pretty interesting. So I have let's see, what am I walking through here? So I basically have, I can also bring up the Excel sheet. Oh no, I don't have it saved. I basically just used Excel, set my initial conditions that I had set up here that I picked randomly, and reproduction rates and death rates, and then just basically have two columns, and one for the prey population, one for the predator population, and ran it over 100 time steps. And obviously Excel isn't like it helps, like you can more or less run a simulation, but it's also not the most dynamic. Order sweeps and all that stuff is difficult. So I was basically just like plugging and playing, messing around with some of the initial parameters to see what happens, and found out pretty quickly that there is, just by messing around, there's actually this sort of inflection point where the predator growth rate is just changing from 1.06 to 1.05, which is the number of new predators that are born, I guess, at time step. And so at that point, there is this change in the outcome where the prey population always outpacing the predator population from there, and never catches up. So that was a random inflection point that I happened to come across, just like plugging in a few numbers, which was kind of funny. And yeah, it basically just got me thinking. So it was satisfying to get these charts and some actual numbers. Obviously, the visuals are cool, but it got me thinking about more about the mathematical relationships between the two variables. So I'm kind of curious now. We'll have to do a little bit more research. I'm sure there's some stuff out there, but I'm curious now how much you can actually learn about the system just from the original differential equations, the set of differential equations that you choose to represent. And so I imagine there's ways to like solve for different variables and understand like long-term equilibriums or steady states at point. Finding inflection points like I was able to do first, but I think that by solving, by messing around with the differential equations and solving for different variables or looking at different ratios and stuff. So that's one thing that I want to do next. I'm kind of curious about just understanding the mathematical relationship between the variables a little bit more. And I'll actually stop. I don't know if anyone, does anyone have any ideas on how to do that, or if I'm even thinking along the wrong lines? It's just kind of like, haven't taken math classes in a long while, so I'm not really sure if that's even the right path to investigate down, but does anybody have any thoughts about that topic?
Yeah, it looks similar to what I've seen in poker. That's all I can tell you, but I don't understand this game very well, or what is the what is that you are calculating?
Mm-hmm. And you said it's similar to which model?
No, to the way we study poker.
The poker game. Yeah. Got it.
Yeah, the poker. You look for correlationships and see if they are useful to get like mental hints during the game, something like that.
Okay. And do you know if, like, were you looking for all of those relationships visually? So that was by running simulations?
You run simulations and you get the expected values and compare them, and obviously try to find the highest for the strategy you are forming. You form two strategies until they reach Nash equilibrium at some point. So you mix them and modify them. You make them and modify them, and if one simulation goes well for one side, you modify the other strategy, and that way until you find some strategies that don't move and they just stay still, like they are the optimal equilibrium.
Yeah. And do you have any idea if it's possible to solve for that equilibrium point, maybe without having to run the simulations, like visually? So do it mathematically.
You can get close to playing like that by logic, but there are things that have been found with the calculators that the humans didn't do before. So I'm not sure if I answered.
No, it's interesting. Similar scenario.
In this case, you're working with differential equations for, I assume you have one equation for predator and one for prey?
Yep. Yeah, exactly.
If you set those equal to each other, then you can see what parameters make both sides equal, basically.
Okay, right. So that gives you like the intersection points or like long-term.
Yeah.
Yeah. Okay.
So looking at the last graph, there must be something. Well, I don't know what the equations are, but the fact that 1.05 and the other one is what, 0.5 in the initial conditions?
1.2 is the growth rate for prey.
Okay. Okay. So there's probably a way to get those curves to be equal. adjusting those parameters.
Mm. Right. Okay. Cool. Yeah, I'll probably start messing around with it.
If you set the equations side by side, then you can probably solve for what would create that equality.
Mhm. Solving for the different parameters.
Yeah.
With the populations equal. Okay. Cool. Yeah, I gotta get back into dig up my old math textbooks or something. Okay, awesome. And so that's one of the next steps that I'm hoping to take. Just learn a little bit more about what we can learn about these systems from the equation. So without having to run simulations, once you're able to set up your system of equations, then solving for, see what we can solve for, I guess. And another, let's do that. And then second next step, I'm also going to try and add in some layer of complexity. So obviously this is predictable, or there's not a lot of variability in any of these 3D charts. So I'm going to see if I can successfully add in a layer of complexity, like temperature spikes or some ecosystem factor, I think, whether it's like a food supply for the prey. I think somebody mentioned that last time I presented too, which sounded interesting. Or random temperature spikes, and if the temperature jumps up to 50 degrees Celsius, then 30% of the predator population dies or something like that. And just see how this, affects the outcome. And then finally, I still don't know if this is possible or how this will work, but I'm kind of curious to go back to, circle back to the cadCAD 1.0 concepts that Tyler introduced the first few weeks, and see if I can explain any of the system in those terms, so the dimensions, spaces, blocks, and points. Obviously won't be able to model anything, but I'm just kind of curious to circle back to that topic, see what I can remember, see how it connects to the system. So that was all the messing around I did last week, but making progress.
That's good.
Cool.
Awesome.
I think
Awesome.
thinking about there was a video with a temperature converter in February that was using the 1.0 architecture, and based on how that was set up, I would expect that you could implement a predator-prey model using the same framework.
Okay. And where do you know where you saw that?
It was one of the cadCAD videos, and I don't know if it was Zargam who was presenting. It was a video on cadCAD 1.0.
Okay. Maybe it was the community call in February. We had a 1.0 presentation. I must have missed that part.
You can look for the link.
Cool. Yeah, I think it should be, if it was a cadCAD video, it should be on the YouTube. Awesome. Yeah, I can check that out. Cool. Any other final comments? I think that was it from the sign-up sheets, unless somebody snuck in there. But yeah, any other final comments before we wrap up?
Thank you for all the presentations. It was great to participate. I hope one day I can do something to show. But yeah, thank you.
Yeah, for sure. Thanks for joining us. We've got going. There's maybe 8 or 9 ongoing projects at the moment, ranging from everything from this Pico DAO, very Web3 focused, to like recurring prisoner's dilemma, and yeah, so wide range. I found it really interesting to be able to listen and just learn. I think myself, I'm probably like more on the non-technical and beginner side of all of the modeling and simulation stuff, but I find it super interesting and exciting. So it's really cool to see what everyone else comes up with. So appreciate, yeah, all the progress that you guys have been making. Sweet. Yeah, any final comments? Otherwise, we can close out a little bit early.
Thanks so much for everything.
Sounds good.
Yeah, thanks everyone for the feedback, and yeah, let's go.
Cool. All right, well, we'll see
Thanks,
everyone
everyone.
next week then. Thanks for joining.
Bye.